So, hi everyone. We are now live, and welcome to the 11th meetup of featurestore.org. Today we have a presentation from Hopsworks, where Fabio will be presenting. And just a few things before we get started, some reminders. This meetup is being recorded, so if you want to have a look at the recording, it will be available tomorrow, as well as Fabio's slides on our website. And if you would like to ask any questions, please use Zoom's function as the Q&A button, because it's easier for us to track the questions like that. But if you want to ask something at the chat, we will just pass it to Fabio, so don't worry. And yes, that's pretty much it. We can get started, and I'm passing it to you, Jim.
No, okay, thanks, Mariana. I think you covered it all. I'll just go through it briefly. So welcome. Today, we've only one talk today. As Mariana said, it's Fabio Busso, who's the VP of Engineering at Hopsworks, and one of the main developers of the feature store at Hopsworks. And he has very extensive experience in this space. He's built a lot, he's worked with a lot of customers, he knows what kind of problems that you encounter. And one of the classic problems is, how do you test your feature engineering pipelines? And he's going to talk about that in the context of Hopsworks. But I think, the lessons for how to build reliable features with modern kind of DevOps, dare I say MLOps practices, will be covered today. So there'll be a Q&A. You can ask questions, as Marianne said, with the chat button at the bottom. Featurestore.org is a community. You're welcome to submit a proposal for a talk. We'll have probably another talk next month. We haven't confirmed exactly. We have two different companies who are talking about it, but there's also a Slack channel. You can go and join it. There's a QR code here you can use to join, or you can just Google featurestore.org and join the Slack channel there. There's also a newsletter. So if you go to the website featurestore.org, you can subscribe to the newsletter, and you'll get the links to today's talk and slides if you choose to do so. So without further ado, I'll hand it over to Fabio, and we have something in the chat, but I guess that might be just a link to our Slack. Okay, so you can go from there. Over to you, Fabio.
Thanks. Let me share my screen. Okay, so thank you everybody for joining. So today we're gonna a little bit talk about how to kind of build reliable feature engineering pipeline, as Jim mentioned, in the context of Hopsworks. But obviously, lessons here can be extended to normal feature engineering pipeline, I would say, right? So before kind of diving into it, at Hopsworks we work a lot with different customers. We work with customers of all kind of sizes, from Fortune type customers to startups. And I kind of a part of my job is also to help those customers kind of get up and running with Hopsworks and be successful with Hopsworks. So I kind of noticed a set of patterns when dealing with feature engineering pipelines that kind of I want to summarize here before kind of digging into why it's worth it to think about building reliable feature engineering pipelines, right? So the way I see it, this is obviously on average, right? So if you don't see yourself here, then that's great, right? But across many different industries and companies and so on, oftentimes the feature engineering pipelines is just a set of notebooks that mix together the feature engineering aspect of it, so the business logic of actually computing the features, together, for instance, with the plumbing code of connecting the different data sources together, the authenticating with them, pulling data, executing code, and so on and so forth. And that becomes extremely hard to follow the code base, extremely hard to understand what's going on, and if there's an issue and you need to maintain that code 6 months in, it becomes really hard to actually read, right? That becomes even worse if the user don't have a feature store, right? So if the user don't have a feature store, oftentimes what happens is that the feature engineering pipeline is actually part of the model training aspect. So together with the plumbing code to connect to the backend services to pull the data, you have the business logic to actually do the feature engineering. and you also have the model training aspect of it all together into a single code base. Really, like, again, becomes hard to maintain. Another thing I notice often is that features are oftentimes like kind of obscure computations that are not well documented in the code. And, you take this bunch of values, you do something with them, like, oh, this is a new feature that we're going to use to train our model. There is no information about what the feature is used for, or like how the feature gets computed or anything like that. So, if someone joins the team, or if you go like 6 months in and you have to retrain the model and so on, that becomes basically impossible. Just throw away everything, rebuild the model from scratch and so on, right? Another like pattern I see often is that, people are fetching features from a bunch of different data sources, right? And each data source has its own characteristics, and might be a backend database, might be some data lake and so on. And that obviously adds to the complexity of maintaining this feature engineering pipeline, and adds to the complexity of actually understanding it. The last one, probably the most important one, is the data is messy. The reality is that you cannot trust data. Oftentimes it's really unpredictable. Even if you train your model today and data looks okay, 6 months in, data might change and the quality might deteriorate, right? So all these aspects kind of contribute to, breaking what's called the feature engineering pipeline, right? And if you look at like where the pipeline can break, right, we have like identified like 4 different areas, right? So the first one obviously is the feature engineering pipeline itself. So the feature definition itself. So the way you have computed features, the way you build features, maybe it's working right now, maybe you go like 3 months in, 6 months in, and decide to do a refactoring or something like that. That like you potentially can break the code that's actually there, right? Or it's not, the feature is not doing what it's supposed to be doing. It's not doing the computation correctly or something like that, right? Another potential point where feature engineering pipeline can break is actually on the execution side, right? So and again, the difference in the categorization between the different areas it's quite fuzzy, right? There's a little bit of overlap between the different areas and categories. Here we can like think about, okay, you're executing your feature engineering pipeline, but you have maybe a wrong condition. Maybe instead of looking only at the past 5 years of data, because that's what regulators tell you to do, you've been looking at the entire history of data. You might have a problem there. Or you're joining different data sources together, and that those data sources are not joined correctly. Or in the case of feature engineering pipeline, you might even be leaking data from the future. So you have a leakage of data in your training data set that can cause problems in the model training and so on. You might also have wrong settings, right? You might be running, for instance, on Hopsworks, you can run Spark applications. You might have like a wrong configuration of the Spark application, right? You might have like a small application, and all of a sudden you start maybe pivoting a massive table, and the Spark at some point says, goodbye, I'm dying, bye-bye. So obviously, this is something that you want to test, making sure everything is running correctly. And finally, runtime compatibility, and that means like from like library dependencies and so on, right? So for instance, in Hopsworks, you can manage your Python environments through the UI. It's like a nice UI to kind of orchestrate that. But the Python environment ecosystem is extremely stable by itself, right? You have like dependencies of dependencies of dependencies, and something gets updated, you don't even know about it, and something breaks. So obviously, like not only testing the code, but testing actually the execution is something critical for making sure that your pipeline is running correctly. Then we have another aspect, is the data itself, as I mentioned, is unpredictable, unreliable, and so on. So you cannot expect that the data always it's always the same. You cannot expect that, potentially, okay, we have the customer ID, for instance, cannot be null, for instance, right? Though you cannot trust that, right? Maybe during the execution of the pipeline, retraining of the model in the future and so on, you have some data somewhere where the customer ID, the backend service is null or something like that, right? You end up with these like weird cases that can break your pipeline, or if they don't break the pipeline, may break the model downstreams that are using those features, right? Another aspect I've seen often is that data volumes actually increase, right? You have processing your 1,000 events per hour or something like that, and all of a sudden it's Black Friday, and you have to 10 times that amount of data, right? So your pipelines might need to be configured, might need to be expanded to be able to handle the load of that one, right? So that's obviously also an important aspect when you're running feature engineering pipeline in production. And finally, the runtime itself, right? We have a class of use cases on Hopsworks that typically is like recommendation use cases where, for instance, it's not only important that the data gets retrieved with extremely low latency, with like single-digit millisecond latency for making prediction, but is as crucial as that the data comes from the backend services and gets feature engineered and gets updated on the online feature store as quickly as possible, right? So you want to have a real-time basically processing of the features and make them available on the online feature store, and then brings up a bunch of additional challenges to make a pipeline reliable. You might have application crashes. You might have underlying data sources become unavailable. You might as well get latency spikes in the feature engineering pipeline. All of this contribute to make your pipeline reliable and potentially crashes and so on. So if we look at like the single individual things and what can we do to kind of prevent the different aspects, right? So the first one is obviously the business logic, right? And as I mentioned at the beginning, right, oftentimes what I've seen when helping someone get started with the feature store is that the entire pipeline, it's actually in a single notebook that does from data sources all the way to model training, everything's done there, right? And if you build another model, then you do the same concept, right? So this is the typical case without the feature store, and here already the Hopsworks feature store by itself kind of had to solve a bunch of different issues, right? The first one is that in Hopsworks we have this abstraction called feature groups. Essentially, they are features that are related to each other, right? And you can think what they are exactly depends on obviously on the use case. Here we have, for instance, a feature group contains like know your customer features, feature group that contains transaction data, feature group that contains user session data, for instance, right? So that by itself, what basically allows you to do as a user is to split up your feature engineering pipeline instead of being a single monolithic pipeline that is really hard to maintain into separate pipeline, which scope is really, really reduced, right? So now, when you're looking at know your customer pipeline, now you know that they are computing only feature engineering, only pipelines, only features for the know your customer feature group, right? So at that point, if you have to maintain, obviously the code base and the complexity, it's reduced because you'll be looking at the single individual aspects one at a time, right? The second aspect that it helps, and that's one of the core concepts of the feature store, it's actually the usability, right? So as you can see in the example, like if I go back here, right, and I'm training, let's say, the churn model, and I want to train the fraud model, then I have to do the same feature engineering aspect again, right? I have to go back and rebuild the entire pipeline from scratch. What I can do with the feature store is essentially be able to reuse those features from the feature groups to build a new train data set, right? And what this buys me as a developer, as a data engineer, is that if I write tests for the pipeline that writes in the know your customer feature group, if I write tests for the transaction and so on, those tests then validate all the downstreams models, all the downstreams training and so on. So I write tests once, and that's basically covers my 10 models using that feature group, right? So obviously that's like people are generally lazy, me included, and obviously if I can avoid doing work twice, then obviously I'm happy as well. So that kind of like saves time and improves productivity. The third aspect is something that actually unique to Hopsworks is that when you're using a version of a specific feature group, right? In this case, the churn training model is using the transaction feature group, for instance. You're not using transaction feature group, but you're using version 1 or like version X of the transaction feature group, right? And what Hopsworks forces to do is to use these versioning schemes to protect against breaking changes downstream, right? So like protecting downstream from breaking changes, sorry. So if you have testing in place, right, and you make a commit and you make a refactor of the pipeline, right, and you try to push it, and the test break, right? So there are two possible outcomes. One outcome is your code is wrong, there's a bug. There is a case where you didn't account for, and you go back and fix it, and you push it again. It's green. Let's merge it, right? The second case is that your changes are actually valid, right? The new way you're computing the feature groups, actually, it's valid, but that's not what the downstream model are actually expecting, right? So you can either create a new feature or you can create a new version of the feature group, right? That allows you essentially to push the changes, right? Push your new feature computation without breaking the models downstreams that are relying on this version to be computing a certain way, right? So obviously, also kind of testing here allows you to decide, okay, the tests are broken. Is this something that I need to fix, or is it something that I need to increment the version of the feature group and increment the migrate the models and so on in the future to kind of use the new version of the feature group, right? So what actually means to actually is like testing those pipelines and so on, right? So if we look at the context of the Hopsworks feature store, the Hopsworks feature store is, I think, the feature store that basically covers the largest number of execution environments, right? So when you operate with the Hopsworks feature store, what the Hopsworks feature store does is essentially pushes down computation depending on the environment you're in, right? So in Hopsworks we provide like pandas, so pure Python computation from a notebook, either running on Hopsworks on external environment and so on, running pure pandas transformation. We support Spark, either PySpark or not like Scala Spark. We already support for Flink. We have some issues set up right now, but we are growing that one as well. And then we have an entire class of feature groups, what we call on-demand feature groups. You can look up on the documentation what they are. But essentially, in a nutshell, they are feature groups where we don't even where Hopsworks doesn't manage the data itself, but only manages the metadata, right? So, and here we have like this Snowflake logo. Essentially, it could be, for instance, Snowflake, could be Redshift, could be Oracle database or something like that, where Hopsworks doesn't store data itself, doesn't manage the data itself. All the data management and actually query processing is all pushed down to the external data source, right? So obviously different targets, different engine and different characteristics and different way to actually test the code there, right? So there are two principles that I would like to kind of use, and one is the shift left principle, where essentially you want to push the finding these kind of issues, finding this kind of like business logic or feature engine definition issues as soon as possible and as close as possible to the development process, right? You don't want to find them when you are trying to train your model and so on, right? And the second one is that you potentially want to run like unit tests, and unit tests by definition should not rely on any external platform and so on. So essentially, what these two principles combined together mean that you want to find the issues as soon as possible, as fast as possible, and without necessarily any integration with any other external sources, right? So if you look at what's possible in this space, right? So obviously, if you're running pandas and if you're running Python, there is the go-to library is actually PyTest. Is a nice library to manage executing tests. Same thing happens if you're running PySpark. If you're running Scala, that there is also a library like Scala test that basically allows you to do feature, like test definitions and execute them. For Spark and the equivalent for Flink as well, the way you write tests really depends on the way you actually write code. So, for instance, like in the case where you're running Lambda functions, for instance, in PySpark, then obviously you can test individual Lambda functions without even starting a local Spark environment, right? Because you test those individually, those units. But oftentimes, I'll show an example in a second. Oftentimes, you're actually doing operation on data frame level, either through like the data frame API or through this Spark API. At that point, you need a Spark environment to understand and execute your code to be able to kind of see the results. And for that, Spark runs in a local mode, and you can run that. For Flink and others, for Snowflake and Redshift, obviously there is some support. For instance, if you're running DBT, that to do unit testing, But oftentimes what you end up doing is actually skipping the unit testing phase completely and write an integration test against the database running, right? And we'll see in a second how to do it essentially. So this is a quick example of the unit testing we're running in PySpark that you can run. So essentially on the top part, we have our transformations function. We basically have a set of transactions coming in for our customers. And we want to see what's the monthly average transaction for any given customer, right? So we group by data frame by customer ID, year, and month, and then we just basically do an aggregation on like an average aggregation. Then we just basically rename the column just to make it easier, right? So the way we test this kind of environments, we're basically at this point not comparing output. Of course, you can use the Python assert library as well. You can basically just throw asserts if stuff doesn't match your expectations. But there are a bunch of libraries, and the one I'm using here is for PySpark called Chispa. I think CHIPS. That basically allows you compare data frames. If you're running Scala Spark, there's a library from Ondemand. She's quite well known in the community, in the Spark community. She built a library to basically compare data frames. Right? You can compare by columns. You can compare by either exactly or by approximation, right? Especially if you're running, for instance, averages with like floating point numbers, then you want to, you are okay with a certain level of approximation. But that's exactly what's happening here. I define my base data frame. I define what I expect in terms of data frame, run the computation, and compare them. If something breaks, then an error is being thrown. And I can run this one on my local laptop. I can run it as part of a CI/CD pipeline. The only thing that is missing from this snippet is obviously the setup of the local Spark environment. But it's like one line of code, and basically you can run it, right? So if we look at the next class of problems, like was mentioned, the execution itself, obviously there is a bunch of more issues that we were mentioning, right? So we want to make sure that the dependencies are correct, that that the actual execution is being done correctly, that you have a more realistic sample of the data, for instance, right? So in the example above, we handpicked the examples that we want to test on. Obviously, there cannot be you can obviously have CSV running around, but the alternative here is basically running it on a cluster where you have a sample of the data, right? And I can show you, I have a small demo at the end where you can these ones. But the basic idea is that you run the same code, but instead of relying on handmade data, you essentially rely on existing feature groups that you have on a special project, on a testing project, where essentially you can pull the data from it. Like in this case, for instance, a line 13, we are making a connection to Ondemand database, fetch some data for the customer transaction, run the transformations, run the feature engineering, and then we have on the feature store itself, we have a feature group called expected transaction data, which is what we expect to get from our testing, right? And obviously all of these are versions. So if you, as was mentioned at the beginning, if you bump the versions, you can, of course, test with different versions in parallel. And we run the exact same assert method that we can check against the two values, right? And this is kind of where we stand as Hopsworks, essentially, right? We recently in 2.5, which is coming out right now, these days, we have support for native first class support, I would say, for Git integration. So you can pull and push to get directly from your Hopsworks platform. So essentially, what you basically do is that you split up your work into different projects. That could be that lead to different feature groups. To different feature stores. You obviously have like a development one where you and your colleagues have freedom of experimenting and be able to create different features, to experiment with different features and so on. Once that is done, it can be committed to a repository, right? And that's where the the automation and testing happen, right? The first test is obviously running a bunch of unit tests. Those can run obviously either in Jenkins, they can run on the obviously on the GitHub Actions or any other platform you're using for feature engineering and sorry for testing and so on. But there is the second aspect is, and I can show you an example in a second, is that you can also from those platform, from those CI/CD platform, you can also call Hopsworks and run the integration test directly on Hopsworks. And you do that on a testing feature store, where again you have to prepare all your testing environment, all your testing data, like a sample potentially of the production data, if you can do that, or like a synthetic equivalent of it, if your production data contains, for instance, PII information. That obviously runs the executions and report back if the test failed, if the job runs successfully or not. Then this is then reported back to the platform, to the CI/CD platform, and then from there on you can decide whether or not you want to merge it to code. All consideration done before, and then if that happens, it can be then pulled back into the production feature store, pull the new changes, and you might have, like, for instance, something a scheduler in Hopsworks. We have support for Airflow, but any scheduler will work that basically kick off a job periodically, and the next time it's going to kick off the job, it's going to pick up the new code. Again, this is kind of where we structure, how we suggest to structure the repository. So then we have every feature group is a different pipeline. So then again, if you go back to the beginning, you can think of as a separate individual entity. A feature group can have a bunch of things. You can have the jobs that computes it, the configuration of the job itself, so that you can do essentially infrastructure as code also for Hopsworks jobs. And you can also have your actual feature definition that actually gets computed and so on, right? So obviously you might have utility methods and files. That can be a Jenkins file, it can be a workflow file if you're running on GitHub. Then you tie everything together, and basically that's your MLOps CI/CD platform. Okay, I'll show you in a demo in a second about this aspect. But if we move on to the other two remaining and to see how let's say the feature store can help you with that. The biggest one, I would say, the biggest source of pain after code issues and so on are actually the data is actually data itself. So in Hopsworks, as a feature store, we allow you to define two different things. One is feature validation. The other one is feature monitoring. They have two different purposes. Let's start with data validation. So the idea is basically you can define a set of rules that your data should have before it gets written into the feature store, right? So that rules could be potentially that it cannot, like a customer ID, for instance, cannot contain none, or that the age of a person cannot be negative, or anything like that. So you basically define a set of rules that your data should look like. You collect those rules in what we call an expectation, and we apply the expectation on one or more feature groups, right? So the basic idea, the way it works, is that when you're running your production pipeline, if there is some data that doesn't match those expectations, right? So if the expectation validation fails, at that point, the data depends a little bit on how you configure, might not be inserted at all, right? So you may say, okay, there is a problem here, right? And there is a problem that needs to be investigated. The data is bad, and if I'm going to insert it in the feature store, all my models that rely on that data are going to break, and then cause like a chain, like a scale of effects. That's data validation, and that takes care of, as I mentioned, certain problems of actually data quality in terms of problem with the data itself, right? The other aspect is actually what we call feature monitoring, right? So here, the difference with the first one, with data validation, is that feature monitoring the problem of the data is not that it's bad data, right? It's that the data does not reflect anymore what your model has been trained on, right? So data has changed over time. Consumer behaviors have changed, right? So you might have to retrain the model, right? But the data per se is not, it's good data, it's not garbage, right? So you have it in the feature store, it's being inserted and updated into the feature store. But you have a background process that now and then checks, for instance, the computer statistics on data, checks if there is drift or not. And if there is drift or not, then someone gets alerted and say, okay, look, your data is drifted. There is a possibility that your model is not performing well enough anymore. Let's go back and retrain. The model, right? So at this point, it's not about the quality of the data, but it's about taking actions about data that's already in the feature store, and it's per se good data. You can be used. It's just action needs to be taken, right? So obviously supporting it with different use cases are what kind of Hopsworks provides as a feature store. And finally, we do have runtime issues. So mentioned at the beginning, one typical use case that we see a lot here at Hopsworks is use cases where not only is important for the inference services to be able to pull features from the online feature store with like single digit latency, but it's also important that those features get updated in real time, right? So obviously, things brings a bunch of challenges that are not only related to the pipeline itself, not only related to the code itself, but also on the actual execution and making sure that the execution is monitored as close as possible, right? So there's been, like, for the past couple of years, there's been quite a strong development in the, let's say, observability space, coming from the DevOps space, right? And there are, let's say, three main pillars here, right? So we have monitoring, logging, and tracing, right? Honestly, the debate is still open on the, let's say, the DevOps community about is tracing really worth the effort? What kind of level of information is going to give you, and when the benefits start over become better than, like, greater than the actual work to implement this and maintain this system. So right now, there isn't really a solution in the MLOps space. I don't think there is strictly a need for it. I think monitoring and logging are kind of two of the biggest components that allows you to really stay on top of the pipeline and making sure that your pipeline is actually still running correctly, right? So the monitoring in Hopsworks, all the applications are being covered by both. Everything you run in Hopsworks is monitored, and everything you run in Hopsworks logs are collected. So we use the Prometheus stack in Hopsworks, where basically all the applications get registered. They basically send the logs to the Prometheus, and those logs are being available either on Grafana to be able to actually see the performance of the application, making sure the application is still running, but also potentially set up alerts, right? So as we were discussing, if I'm relying on features being engineered in seconds latency, almost real time, even like lower than seconds latencies, at that point, if something happens, I want someone to be on top of it and make sure that those pipelines are being taken care of, right? So here's where the monitoring observability and enters the picture. And it can be a simple, the pipeline is crashed and there's no more information coming in, but there might also be more complex scenario where the latency spikes for whatever reason and someone needs to investigate, right? The other aspect, obviously, is also logging. When running applications, all the logs are being collected and made available in Elastic, so they're indexed, and you can use Kibana to actually look into those examples and so on. And so you can basically follow the logs of execution. If there's anything being broken or like any problems, you can obviously dig through the logs real quickly with the search. Okay, so this kind of covers like the biggest part of the presentation. I think we have questions at the end. I just want to kind of show you a little bit of like the setup that we kind of have in Hopsworks, and you can use to actually test your pipelines in Hopsworks as well. So recreating this aspect here that we were mentioning before, like your development and feature stores and so on, right? So in Hopsworks 2.5, I think. Let me see if I'm still logged in. Yeah. In Hopsworks 2.5, we added support for Git, as I was mentioning. You can track your own Git repository here. you can clone some repository from GitHub, GitLab, and Bitbucket. You can obviously manage this repository. You can push changes, commit changes, and so on. So if you're doing like Jupyter-driven development, all this can actually happen. But also the opposite can happen, right? So you can also pull changes from a repository into Hopsworks to be able to run these execution tests. And that's actually what this repository is actually doing. So here I have, for instance, the code I mentioned before. So I have the know your customer transaction, and trying out the different feature groups, run the executions, and calling the assets, right? The only thing I did before that is making sure I installed the library I was mentioning before. That is the one that is responsible for actually doing the comparison. And in Hopsworks, you can do that by managing your Python environment here. You don't have to write any Python code, any Docker file. All of this is handled by Hopsworks. So you just have to install a library and off you go, right? So I set up my repository. There are a bunch of keys to set up because I need to authenticate with GitHub. And essentially what happens is that I have the two feature groups I was mentioning in my code, right? So if I go back to feature group, let me filter the garbage out. Yeah. So now we have two feature groups for this meetup, right? We have the my external feature group that is basically pulling data from a backend database. And I also have the feature group with my expected data, right? At that point, for instance, you can run the code. Basically, you can go into your jobs, configure your job, and essentially be able to kind of execute your tests and so on, right? And all of this, I was kind of experimenting with it. All of this can be, of course, driven by GitHub itself. Right, in GitHub, if you're familiar with that, you can define workflows. Essentially, what you do is, and let me zoom in a little bit. Essentially, what you do is that you need to define install our library, HSFS library, and from there on, you can basically call like a utility method that basically runs the test on the cluster. Right. So this is just a wrapper for doing authentication with the cluster and submitting jobs and making Hopsworks pull these changes. So the way it works essentially from a platform perspective is that you automatically using the REST API is gonna basically pull the latest changes and go into jobs and submit a new execution of the job. And all of this is done behind the scenes. And if there is an issue later on, then everything is obviously reported on the GitHub Actions here. That allows you to kind of see where, if anything failed or what failed and so on and so forth. Yeah, that's all I have for you today. If I go back here, slideshow, yeah.
That's great. Thanks, Fabio. Thanks very much. That's Hopsworks AI is the URL here. We have an opportunity to ask questions now. There's a couple of questions in the Q&A. Try and use the Q&A button. And I'll start with Christian Raggi. And Christian asks, what if models have model-specific transformations? Do we have then a feature store for each model?
So it depends. Well, so you don't. At this point, you would be talking about like feature groups. But it depends, right? It depends what kind of transformation, model-specific transformation you are applying, and how specific is, I would say, right? So we do have a certain level of transformations that can be applied at model. What we call a trained data set, essentially, is the unit that allows you to actually train your model on top of the data. No transformations can be, for instance, one-hot encoding. It could be a normalization of some data, right? And you do that on a model basis because you might be chunking data in different way, depending on the model and so on and so forth. So those kind of transformations do not need to be created. You don't need to create a brand new feature group every time.
So you mean you just to clarify, you mean you can apply the transformations after you retrieve the features from the feature store?
Yeah,
so
exactly.
not before you create the features.
Yeah, exactly.
I think that's one of the things that people get confused with. It's like if you apply the transformations before you create the features, they're less reusable because then you're forced to use that transformation, whereas you might want a different transformation for a different model.
Again, from experience, it really depends on how. I think it's a trade-off right here, right? So you want to see, okay, how likely I am to gonna use this feature, or how likely I am that I can compute it on the fly. And I think here there is no like right or wrong answer. Generally, of course, if you have it in the feature store, like if as part of a feature group, you have much more benefits. Like you can, apply, as I said, data validations. You can apply, of course, testing and so on and so forth, and that allows you to kind of be more certain of your transformations. But if there are certain levels that you cannot do before, it doesn't make sense to have it before. As I mentioned, normalization or like maybe one-off encoding or like some really specific to a specific model. At that point, yes, we do as Hopsworks feature store. We allow you to kind of run those transformations after you have written into the feature store. So at the moment where you are basically retrieving data from the feature store.
And they're basically Python functions applied to individual columns in your or features. Yeah.
So they are basically
Honestly, I think this kind of debate has been skewed somewhat by having extremely large companies leading the debate in feature stores. So when DoorDash talk about many terabytes of data and how they have to compress it, they obviously apply their transformations before the feature store because they're not going to be reusing that feature, and they care about having terabytes or many tens of terabytes of data in their feature store. But for people who want to reuse features, I think applying feature transformations after the feature store makes a lot of sense. So we have an anonymous attendee. It's always nice when we get non-anonymous questions, but this one says, can I do Hello World of Hopsworks feature store on my laptop to try it?
Yes, you can go on Hopsworks.ai and its platform. You can either connect to your AWS account, but you can also use our demo cluster. And we have a demo environment that you can get for free.
I think the person is implying, can I run Hopsworks on my laptop?
I mean, as long as you have a good enough laptop, then you can do it. We have an installer script that you can find in documentation that you can definitely run.
I think you need a good bit of memory and a bunch of cores to get it done. And Linux.
But definitely, like my suggestion is try out an Hopsworks.ai. It's the same experience at the end of the day, but you don't have to have a bigger laptop, I would say.
Now we have another anonymous attendee asking a question. How many columns can Hopsworks feature stores support?
It depends what you're doing with your feature groups. We do for the we'll go offline feature groups. It's pretty much unlimited. The online feature store, because it has low latency, because it has a certain level of characteristics that would enable essentially the low latency retrieval as a limitation on the number of columns. I think it's like 512, I think. That means though, if you have a lot of more feature groups, and that's what Hopsworks does, is essentially, if you, let's say you have a model that needs like 10,000 features, those features can be taken from different feature groups and joined together afterwards. So even if you have like a large data set, even if you have a large set of features that you need on the online feature store, it can be spread up and be able to store all of them. But again,
question is, we have a question came in on the chat by Peter Zawadzaki, not on the organized, but it says, when your feature logic is in SQL, do you need to unit test SQL syntax? Like you've tested the average function in the unit test example. I guess you're hinting at DBT, Peter, there, I guess.
Yeah, no, I mean, no, I get the point. I mean, the example was like quite simple, obviously, right? I mean, there wasn't one that wanted to make across, right? The thing is that you still have potentially more complex execution, right? You might have been doing, for instance, window aggregations. You might be doing like, lagging or other like type of operation, which the method itself it's okay. It's quite trivial, right? And you can probably rely on the underlying system to be tested. But the way you're using it might be become problematic.
I think aggregations is a good example, because you might have like a window of time where there's no events arrive, and you want to make sure that the aggregation won't just crash. And you might have other times where you have large numbers of events, and you want to test these different use cases. And you can test them statically, of course.
No, but again, I get Peter's point and say, okay, this, maybe the average point wasn't, a complex use case enough. It makes sense to set up everything, but like, in reality, this is not the use case you're gonna add, right? It's a much more complex, right? And then you might have situation where you be looking at someone, you set up the data. You might have situations where you're taking that average and make it as part of a bunch of other features and so on and so forth. So obviously the example can be way more complex in real life.
Sure. So we have a question from Pigeon Master. Cool name. Does Hopsworks support, I think this is about on-demand feature groups. Does Hopsworks support importing features in the form of Parquet formatted files with or without compression?
Yeah. We like you can define on-demand feature. I entered at some point in the presentation about on-demand feature groups, right? Essentially, as those feature groups that do not, where Hopsworks doesn't manage the data, right? The data is managed by some underlying system, whether it's.
I think they're better known as external tables.
Yeah, exactly. But
not a great name next to on-demand feature groups, so they're well known as external tables.
The metadata there is being managed by Hopsworks, right? You have pretty much almost all the functionalities, and you can look up in documentation like the kind of limitation of the on-demand external feature groups. Yeah. But the type of we support essentially two types of system as a target data storages, right? We can support data warehouses that basically you can throw basically a SQL query at it and get back some data, or we support data lakes, including Delta Lake. So essentially, S can be S3, it can be ADLS. We are in support for GCS as well. So essentially, where we have a collection of files, whether those are CSV, Delta Lake, org files, Parquet files. We can essentially punch Spark to basically read that one.
So basically, you can have any offline feature store you want effectively. So all of these external stores can be in either your entire offline feature store or just part of your offline feature store. But the fact that Spark is used as the join engine to join features together means that you can support multiple different backends.
You can pull exactly. Yeah, you can we have cases where we're pulling some features from, let's say, S3. We're pulling some features from Redshift, and we are joining them together and potentially create the right features, or also directly go and train the model, right? So you have the flexibility of basically interacting with many other systems. And the nice part about the API is that it's a single front end, right? So the way you interact with the different systems, it's through the same API, right? And at that point, you all the authentications and connections and so on are all hidden behind our API. You configure it to the UI once, and you can use it across many models and so on and so forth, right? So
and then the join engine gives the advantage, I guess, that you can now have your data spread across many different enterprise stores and still join them together. Whereas if you just did everything in Snowflake, well, then you couldn't have data outside of Snowflake, right? We got a couple more questions. Let's try and move through them. From Brehaline, is not the daily topic, but could you introduce main difference between HopsFS and Feast? Okay, I think HopsFS is a file system. Yeah. So it's Hopsworks and Feast. Do you want to say a couple of words on that, Fabio?
I mean, there is a bunch of differences. I would say what we're doing with Hopsworks is a lot also targeted to kind of enterprises. We do have a bunch of functionalities that are, I think, key to actually use really efficiently the feature store. That could be potentially like the UI, for instance. All the feature registry, all the UI that is not only read, but you can also interact with the UI. So we have users, especially like data scientists, data analysts, that want to be able to use features, right? But don't necessarily want to code. They can do that interactively through the UI. That's something that Hopsworks offers uniquely, I would say. Again, this a bunch of other features indeed that allows us to kind of, for instance, pull data from different underlying data sources, as we were talking about right now. Features like data validation, features like data statistics and data monitoring, all of those are part of Hopsworks. And I would say necessary when you are serious building a feature store.
Okay, so we then have another anonymous person asks, Do you have any recommendation for storage technology for Hopsworks in on-premise environment? So, where would you store the data in an on-premise environment?
So we do have. If you're storing data, you will be storing you'll be storing
commodity hardware
on spinning disks. Like it's basically Hopsfs, right? So if you are on the cloud, then we have some unique technology that allows you to kind of offload that storage on the S3 or ADLS or DCS. That allows you to essentially don't store it on a cloud technology. Because if you're on-prem, you kind of need to store it.
There is actually a connector for Hopsfs to the object store in OpenStack. So some people on-prem do have S3 like APIs for their on-prem setups. So that's one other opportunity. Okay, I think we're done for questions, and thanks a million, Fabio. It's been very interesting, and I think this is a really interesting area, particularly for engineers who want to build reliable feature pipelines. I think a lot of people have been thinking about it for a long time, so it's great that we had this. And thank you everyone for joining, and see you all at the next meetup.